Okay, so this is lesson 4, and I'm starting with the vocabulary to remind you to start working on this. Look them up on YouTube, online, and Quizlet, when that's ready, I will let you know. Be prepared to review that next week before our test. Okay, so I'm going to do a little fun thing for this video lesson. I'm going to add a secret word of the day. All right, so you need to listen closely, and I may ask about this in class in a few days. All right, so our objectives, we are going to distinguish or define the term orbital. We will identify and define isotopes, which we actually kind of done already. We're going to write electron configurations, generate Bohr diagrams, and differentiate between kernel and valence electrons, as well as draw Lewis dot diagrams for an element or an ion. So remember, ions have a positive or negative charge due to loss of electrons or gain of electrons. So let's start electron configurations. Electron configurations can be found at the bottom left-hand corner. Okay, so electron configurations, the dash chain of numbers found in the lower left corner. Of an element box, so see below right here, tells us the number of energy levels as well as the number of electrons in each level. And this tells us how the electrons are arranged around the nucleus. So here we have 2-4. So this is telling us that we have a total of 6 electrons, okay, 2-4, right? If we say 2 plus 4, it's a total of 6 electrons. There are 2 orbitals, or energy levels we should say, and there are 2 in the first, 1, 2, and there will be 6 in the second. Okay, just like that. So I didn't do that very even, but it's okay. We're just showing there's 6 on the second energy level, 2 in the first, and it is in that order. So there will be no more than 2 in the first energy level and no more than 8. So we're going to talk about that in a second. But if we just look at the periodic table, all electron configurations are neutral. So this is based on the fact that we have the same number of protons. Don't forget that, number of P's here, protons. And this is equal to the number of electrons when they're all neutral. Different when we have an ion. So for magnesium, the periodic table says it's 2-8-2. So there are 1, 2, 3 principal energy levels, and the first energy level has 2 electrons, the second energy level has 8, the third energy level has 2 electrons. Now if we add this up, we get 2 plus 8 is 10, plus 2 is another 12. Check your periodic table. The atomic number is 12, so we have 12 protons. We're going to have 12 electrons, and that matches. Now we have magnesium ion plus 2 charge. This means that it lost 2 electrons. Therefore, we have to take those 2 on the outer energy level off. All right, so now the electron configuration for magnesium ion is 2-8. The 2 electrons on the end, or the outer energy level, have been lost. Bromine. Bromine is 2, 8, 18, and 7. 2, 8, 18, and 7. So there's 4 energy levels, 1, 2, 3, 4. 2 in the first, 8 in the second, 18 in the third, and 7 in the fourth. The bromine ion, now it's negative, so this means it's gained 1 electron. Therefore, the electron that is gained is going to go into the outermost energy level, not the first, So we're going to have 2, 8, 18, -8. That's the extra electron in there. Barium, I'm going to scroll down a little bit. Barium, 2, 8, so this has many. 2, 8, 18, 8, and 2. Okay. The next one, and we did all these above. Lead is going to be, and this is an exception, because the orbitals, okay, are listed after the first 2. So you have 18-32-18-4. Okay, so here this asterisk is a shortcut that allows you to cut out the first 2 orbitals to shorten the address, basically. This is the address for the electrons, saying this is where they are all located. All right, so this should be 2-8, which would be the first energy levels, and then we would have the subsequent. So here would have 2 energy levels, 3, 4, 5, 6. So lead has 6 total energy levels. Valence electrons are the electrons that are found in the outer shell or outermost shell. We're going to say that, outermost shell or orbital. And the last number in the electron configuration. So if we have 2-8-2, this number right here, this one, will be the valence electrons. And that would tell us there's 2. All right, kernel, word of the day, secret word. I might ask you about that in class, so pay attention. Kernel electrons are the inner electrons, like the kernel of a piece of popcorn inside, right? The kernel's inside the popcorn. So these are the inner electrons, and they are considered all non-valence, not outer. All right, so sulfur has 6 valence electrons. The kernel on the inside is 10. So when we look at the periodic table and we look at the electron configuration, 6, okay, it's 2-8-6, valence, and then everything else are kernel, and that's where we get the 10 from. Okay, nitrogen, valence electrons are 5, kernel electrons 2. So this electron configuration will be 2-5. So now we have to talk about the principal energy levels. Okay, so an electron energy level contains a certain number of sublevels within that. Sublevels. And they are labeled S, P, D, and F. Now, the Regents doesn't ask us about these anymore. We used to talk about upspin and downspin for each electron, but we're not going to get into that, so we will talk about this a little bit in class, but that's about it. Each sublevel contains one set number of orbitals. So you have orbits, the paths, and then you have orbitals, okay, inside each sublevel. So it's even more convoluted, something within something. Maximum number of electrons in an energy level, we use this 2n to the second. Okay, we use this general equation where n is going to equal the quantum number or the period number. So the period number is found on the periodic table. These are the rows, the rows that go across. Okay, so period goes across, and the numbers are listed on left and go up to 7. Okay, So there are 7 periods on the periodic table. So let's look. Principal energy level. There's one energy level. It can hold a maximum of 2 electrons. So we're going to say 2n to the second, right? If there are 2 energy levels, 2 times 2 to the second, right, which is 4. So 4 times 2 is 8. All right, if we use this, again, I'm going to help you out here, 2n to the squared, and this is equal to n. So 3 to the squared, 3 squared is 9, times 2 is 18. So this is the maximum. Can hold less, but this is the most. And then 4, all right, if we're going to say that 4 is equal to n, and we use this general equation, 4 times 4 is 16, times 2 is 32. And generally, we don't really go past that for the regions, but we can just use this general equation to tell us. So if we go on, okay, anything in period 5 and 6, we'll use this general formula to figure out how many electrons are in those principal energy levels. So here's a question for you. What is the maximum number of electrons that can occupy the 3rd principal energy level in any atom? Well, we're going to use our general equation, 2 times 3 to the second, okay, right there. Let me fix that for you guys. It's not so sloppy. So we'll say 2 times 3, principal energy level, squared, is going to equal 18. All right, so I'm going to stop here for right now, and we're just going to focus on principal energy levels and electron configurations. We'll do Bohr diagrams and Lewis dot diagrams for the next video lesson. Secret word, kernel, and be prepared to give me the definition of what a kernel electron or the kernel electrons are.